Please excuse the audio quality, not in a studio environment. So this is the presentation of the software requirements specification draft for PG30 on the 22nd of August 2017. So what we're going to be talking through is the features of the lunar rover exploration system, which includes the following features: an interactive map which allows for control and display of data. The resulting data is an XML GTD data format. We're able to control the vehicle to move to a start location. We're able to move to a location during the exploration period. It's important that we're able to make an emergency stop, and it's also important that the vehicle can explore autonomously. And to make sure of a safety requirement, there's a hazard avoidance requirement in the specification, and once complete it will return to base. So I'll just quickly go over these features in fairly broad sort of detail. So what we've got is, to explain the system's probably easiest just to be able to visualize what it would look like and how it will work. So we've got a map here which will bring up a user interface which has typical features: file save, file load, preferences for configuration. The most important visible feature here is the emergency stop button. We want users to be able to interact with that quickly. So the operation would go such that we connect and then move with manual exploration mode by moving forward, left, right, to set the home location, and then we can go into explore mode and set the travel and turn speed to be acceptable limits so that it can avoid the no-go zone, which would be created with the add no-go zone and delete no-go zone buttons. While the exploration is taking place, we'll be getting feedback on the display system, which will be moving through the area and displaying where the sensors and the wheels and the speed of the vehicle is going, and will also be giving feedback through the console here. So the main purpose of the interactive map is to produce data for the client, which will be an XML document of the map, and that'll be stored in a DTD which will be given to us, the client, in coming weeks. The map will store data from the sensors, and it'll be the location of the sensor data within the XML, which will be the primary store of the data, as well as features on the map, if time permits, of where the trails are and where the landing site is, if discovered. The manual control feature, as mentioned earlier, will be to move to a start location, which will include simple controls to move forward, backwards, left and right, and control the speed, as shown here on the user interface. Forward, back, left and right, controls the travel speed and controls of the turning speed. Then once it's moved to location, moved to the start position here, then we'll be able to move to any location or coordinate on the map, which will be by specifying a horizontal and vertical coordinate, and we'll use a pathfinding algorithm to find the safest direct path to that location. So we can see here on the interface, go to X, Y, and we'll give the X and Y coordinate, which is the vertical and horizontal coordinates. So while moving around in manual mode and in move to location, we have a safety feature, which is the emergency stop, which can be user activated or autonomously activated by hazard detection, and will be resumed by manual override behavior, and then how it will pick up will be determined by the pathfinding algorithm that we haven't designed yet. So this safety feature is the emergency stop, which is the most direct feature on the map here. So the bulk of the time is going to be spent in automated exploration. So the map will start out in an unvisited state and the sensor will move over visited areas until they're all visited. Mapping will be complete when all reachable areas are visited. While it's doing that, it'll have to avoid hazards and no-go zone, and the software design will implement the algorithm to do this. But we've got a rough idea here. It's kind of like a lawn mowing algorithm where the sensor will sweep over the area. The sensor's a small amount of area compared to the size of the vehicle, so the orientation of the vehicle is going to be important while it's sweeping over this area. So while exploring, the hazard exploration is going to be an important thing. It needs to avoid crater zones, it needs to avoid the GPS map exents, it needs to avoid the no-go zone, and it needs to avoid placing 3 wheels into the avoided 3 zones above. It's considered a high-risk incident if the wheels go into those areas because it may not recover, and the pathfinding algorithm, which will be part of the software design, is going to include avoidance in its invariant conditions. So we can, once we come to a hazard, we can emergency stop and then resume, or if the algorithm is intelligent enough, it can turn away from the hazard and continue on. One of the hazards that I've failed to put on this slide is a bump detection, which will be if it collides with a physical object at low speed, then it will avoid that. Sorry for missing that off the slides. So return to base is the final feature. So on completion of the mission, once all the areas that are visitable are visited, it will return to the start and avoid hazards. So we can see that on the user interface up here. So if we come down to here and we've finished exploring, then the sensor would move back to the initial start position, avoiding any hazards along the way that it's already previously discovered in its map. So if this weren't pre-recorded, I'd allow for questions to be answered at this point in time.